In this video, we will discuss how to calculate the energy and power of discrete signals. For a discrete signal, the energy and power is defined by using these equations where E is equal to limit n tends to infinity and the sum from n minus n to plus n, where x of n whole square. And the power is given using this equation limit n tends to infinity 1 divided by 2n plus 1 and the small n from minus n to n, where x of n whole square. If the signal is of finite duration, then you need to remove this limit and you can insert the range from any value of the signal starting and the ending, maybe from -2 to 5 or from any value where the range of signal you need to insert the limits of that sum. All finite duration signals of finite amplitudes are energy signal. You note this point, so this is very important point. The second point is that all periodic signals are power signals, but all power signals need not to be periodic. For example, you know that the cos signal and the sine signal, so they are the periodic signals. You know, periodic signals means that if the cycle of the signals is a repetitive, like for every period the cycle will repeat itself, and such signals will be known as a power signal. But you know that for few signals like random signals, or you can say that the DC signal, so they are not periodic signals, but you can easily calculate that the signal or power signal. So that is why you can have this definition that all the periodic signals are power signal, but all power signals need not to be periodic. There is another formula that you can calculate the average power. So average power is equals to the amplitude divided by 2 under root whole square, or you can write the same formula like a square divided by 2. In this example, we need to calculate the energy and power of a signal where x of t is equals to r of t minus r of t minus 2, and the energy of the signal you need to calculate is yt, which is equals to d by dt x of t. For example, you can draw that signal x of t is equals to r of t. So r of t is a ramp signal, so you can drive that ramp is the from 0 to infinity, and this r of t minus 2 is again the ramp, but it is shifted, where you can equate t minus 2 is equals to 0, and you know the shift start from, so the shift start from t is equals to 2. So you know that it is again a ramp signal, but is a shifted version. So if you just subtract r of t from r of t minus 2, you will end up with another signal which is x of t, and then you can calculate the energy of x of t. You know, these energies from 0 to 2. From 0 to 2 is basically a ramp signal t, which is equals to t square by 2, the limits from 0 to 2. And if you insert the limits, you will end up with the energy which is equals to 2 joules. But from 2 to infinity, it is unit step signal, which is a power signal. So you know that it is a combination of energy and power signal. So if you have energy plus power signal, so the solution will be always a power signal. Second, you need to calculate the energy and power of this y of t, which is the derivative of this x of t. So you just write the derivative of x of t, which is r of t minus r of t minus 2. So you know the integral of unit step is the ramp function, and the derivative of the ramp is the unit step. So that is why you can write the answer of this equation y of t is equals to u of t minus shifted version of unit step. And then you can draw that signal by using this graph. You know the unit step starting from 0 to infinity, and second is the shifted version of unit step starting from 2 to infinite. So if you get the resultant of these two signal, then you can see that this signal from 0 to 2, there is a signal, but this signal actually started from 2, so that is why u of t minus 2, the answer will be this one. And then these two signals from 2 to onward they will cancel each other, and you see there is a 0, and then you can calculate what is the energy of y of t. So energy of y of t is equals to from 0 to 2, it is unit step, and you know the integral of unit step is t, and the limits from 0 to 2. So if you insert the limit, you will see that the energy is 2 joules. So it means that yt is an energy signal having an energy of 2 joule. So if it is an energy signal, then we know that the power of the signal is 0.